Hi. So we continue our conference with the next speaker, Andrii Syniuk. He is working as a tech lead of data infrastructure platform and have experience of over 10 years in industry, coupled with business domain expertise in fintech and healthcare. His technical background includes building of domain-driven design systems, cloud-native solutions, and data platforms. So, please welcome Andrii Syniuk and his talk, Data Mesh in Kubernetes.
Hello, everyone. Happy to see everybody. Okay, I don't see anybody. But I hope you will enjoy my talk about data mesh in Kubernetes. This talk is specifically designed to be Kubernetes focused and about data mesh, basically. First, our agenda for today would be introduction. That's what's happening now. Data storage and analytics evolution. What is data mesh? Motivation for us to use it, components, implementation, evolution, challenges that we face during all of those processes, and of course, Q&A session for questions and answers. First introduction, who am I? I am domain-driven design enthusiast, started my career as a software engineer, pivoted into site reliability field, data ecosystem tech lead as of now, and I'm quite curious about data, therefore working with the data mesh as of now. Below you can find me on LinkedIn if you care. Anyway, let's go to the fun part. Data storage and analytics evolution. Data analytics is not, it's quite fresh field, so to say. It's not as old as software engineering in general. Therefore, it took a lot of approaches, took a lot of inspiration from software engineer design, and was evolving constantly. Modern software architecture, what you can see, it is not very modern, probably. All of us were facing some monolithic architectures. This one is quite service-oriented. You can see some decoupling happening here. But in general, whenever you start a small startup, you investigate into it, you hire a team, and then you start building. The first and the easiest one usually is a monolithic architecture. Whenever there is a server and some front end, some back end running there, of course, you use some cool techniques here and there, but to implement microservice architecture from the go, it is rather difficult and talent-wise expensive decision. Therefore, majority of the companies start with this, what you can see. There is a database, usually that single database that eventually will get sharded, eventually will get replicated. There is a monolith application that is growing, and if structured properly, that will last you for some time. When you start digging into data, and what you can do with that, you try to build some business cases for your business to utilize to benefit from. You starting building a platform for storing the data that would be in future use for analytics. Usually that ends up with a data warehouse, and it's growing. The approach, the structure of the team and approach basically stays the same. You have your backend engineering team, your front-end engineering team, and then data analytics team. They provide you with business insights, they dig deeper, and hopefully they will find something that will help your business to grow. That sounds good, and the solution is working, of course. till you reach some limits, if there are any. After that, probably you would try to improve your architecture. When you're scaling up already, you might come to the software architecture known as a microservice. Microservice architecture pattern you can see in front of you that basically includes a bunch of microservices that are end-to-end solution, right? They are responsible for some functionality. It is decoupled. If everything goes cool and well, probably you're following domain-driven design principles and you have domains dedicated to some functionality that represents business domains. That is usually how you decouple, as software industry is mostly created and exists to help business, and therefore it tends to replicate business structures of companies. This looks quite scalable. You start your team as a bunch of front-end engineers. Also, you build self-independent, so to say, teams that include front-end engineers, back-end engineers. In future, it might include data analytics that are working on some features. They are basically independent. They use all of the benefits of the microservice architecture, and they ship isolated features, functionality, serve isolated domains. And that is much more scalable when you scale your business. When you are becoming a scale up, getting a bunch of investors giving you money, and therefore you finally can make your product as you envision it. For that, of course, you need to increase hiring, you need to standardize technology stacks, and factor a lot of nuances here. That's how it usually looks like, regardless of infrastructure that lays behind it. And that is the most recent, so to say, go-to architecture. But this talk is actually about data mesh. So what is data mesh? Data mesh, it's a concept of, usually I describe it as a microservice architecture applied to data. Main principles are data is a product. You treat your data that you expose as a product, as a self-sufficient product that would be up for consuming for other teams. It also includes federated governance, which is a very important part of any company, I would say. You need to have a control over the topics, who can assess what, and so on, so on, so on. Domain ownership comes from the idea of microservice architecture, of domain-driven design. Team owns the domain as a software domain, as a business domain, and therefore as analytics domain. In this case, a team that exposes data is responsible for quality of the data, of interfaces, of all of the things that are needed to discover this data and to work with it. And last but not the least important one, self-serve. Recently, one of the latest trends in a software architecture and also engineering is platformifying everything. Whatever you have, make a platform out of it. If you can make a platform for platforms, good for you. Why it is a hot topic those days? Because it enables people to utilize the common infrastructure and in some cases serve themselves. They would go to some backstage endpoint, actually not endpoint, but UI, would pick the service that they need, the scaffolding architecture for that, some skeleton, some templates, and in few clicks they would be able to provision the new service with all of the resources required to run it, with all infrastructure as a code that you can imagine this service might need, or sometimes might not. And this is very important parts of independence of the team. That impacts the velocity of the team and therefore the time to market for features and would you beat your competition or not? Or will you at least catch up with them? Those are main principles that are related to data mesh. I would say not only the data mesh, but also the software side of architectures those days. Why would we do that? Why us as PwC Germany would dive into this mesh? The answer is also reflected in the structure of the company. PwC in general, it is a global brand, while each territory, names Germany, UK, USA, is acting independently. In each of those territories, there are partners of those organizations, and they also act independently. When everybody around is so independent, they need some place to run their architecture, for example. Usually the cycle is you start with some monolithic parts, then you try to decentralize things around so people get more freedom and can achieve more. But over the time, you'll shrink again in some cases to centralize some of the core features or core functionalities and structures that you need. For example, let's talk about data. Let's take, for example, the publicly available data. When everybody assesses some data points for public open source data, they would implement different ways to assess it, to work with that, to clean the data, and therefore there would be a lot of redundancy, a lot of things, the steps that you could have done once only. Also, you need to govern access to this data, and here we come. Why we do that? It was working just fine yesterday, 2 days ago, 1 decade ago. It was always working just fine as it was before. But while the whole world moving forward, you probably should too. What it brings us reusability of data products like public information and so on. Faster time to market when you have standardized interfaces to assess the data. It's much faster to produce any analytics and make any decisions based on it. And of course, decentralized data teams. When they are working with that basically enables for everyone to work with the same data and in different ways, the ways they prefer. Components, implementation, evolution. I would share the components that we built it from. As you remember, we are using the Kubernetes a little bit on the top. We are on the bottom of it lays Azure cloud, but we try to build our infrastructure as much as independent from vendor logs as possible. Also, I'll share the implementation, how all of it works, and we'll discuss a little bit of evolution side of those components. There is a bunch of software here, right? A lot of resources: Kubernetes, Apache Ranger, Cert Manager, Helm, Istio, dbt. Who works with data probably heard about some of those, like dbt, Hive, Trino, Apache Atlas, Data Hub. Those are great products that we try to implement in our system and offer to various data analytics teams. Of course, we are not providing them just Kubernetes clusters, right? And a bunch of Helm charts. We try to build out of all of the tools that are requested from us something reusable that can be used in future by each and every team that joins our data ecosystem. Whenever you want to expose data or consume it, you're probably going to us. Our landscape and kind of architecture looks like that. We have governance domains, data products, pipelines, self-service, in this case Backstage, and I would call it query services like Trino and Apache Superset, but I wasn't sure how to call it in this presentation. As you can see, we are using Ranger, Keycloak, HashiCorp Vaults, Data Hub, Apache Atlas, Create Expectations, this little G on the governance side, G logo. All of them should work nicely and coupled to ensure our governance. Apache Atlas is used for governance for as a data catalog, Data Hub mostly as a data catalog. Create Expectations, if I'm not mistaken, this data quality tool that also falls under governance domain. Keycloak is a nice tool that helps us to track all of the users and what they can assess and what's not. And Apache Ranger enforces policies. Why this setup for governance? Apache Ranger is a known project, known product that is on the market for a while already, and it helps us to establish governance on a, I would say, low level. It have a good connection to Hive. We can control down to table and column level the access that user have with the policies of Ranger. Unfortunately, it's not infrastructure as a policy solution, but everything stored in a database. But that's a topic for another discussion. Superset and Trino are used to query and assess all of the data products. As you can see, we can have multiple ones, and we do have multiple stakeholders that store their data with us. Of course, we also provide them means to work with that. For example, Jupyter notebooks. We use Hive to connect to S3 endpoints, to database, you name it, Postgres, Microsoft database. Also, we use Azure Data Lake, those days Gen 2. But whenever you work with products, we already covered the governance part, we covered the querying part, but how does data get into those data products? It comes from different pipeline solutions like Kafka, Apache Airflow, Argo Workflow, if you wonder what this squid doing, Apache Spark, Apache Camel, and dbt, why not? Yeah, all of those sources are available for you to ingest your data products, which would somebody in the future query and build analytics, build Power BI dashboards, whatever is considered valuable out of it. Last and not least, self-service domain. That's basically consists of Backstage and all of the integrations to it. I didn't mention them here, but you can imagine that we are building some kind of forms that help you to spin up data products, that help you to spin up some integrations that basically serves as documentation parts for your teams and self-service endpoint. That is very important part of the whole setup. Of course, you can live without it, but then there would be some bottlenecks, and of course, you would need probably some different decisions based on amount of your customers. For example, if you serve one team, that's quite easy to provide the whole setup by yourself, right? When you serve like 20 teams, 50 teams, that would be rather annoying part of your job. So to automate and give as much power to the user to do whatever they want, whatever they consider will bring value, we use Backstage, of course. Challenges that we are facing, we were facing, and probably we will as well. One of the challenges is policy as a code. Me as a tech lead, I prefer to follow the GitOps way. And as I mentioned before, some tools do not offer that. To make sure that we can recover from anything, that we can restore our environment to the best of the state, preferably the state just before the disruption. We do take some roundabouts. As I mentioned already, we prefer everything to be in a GitOps way. That's why we have part of this infrastructure as a Argo workflow and what's not. We decided, for example, to put policies for Ranger into some JSON files, which then get synced with the environment. And for that particular case, we developed our own operator. So we always can be sure that we are using whatever is in a Git, right? Data quality. It is a very good question. Usually that's not concerned for my particular team. We strive to we basically try to provide the best environment for others to thrive. And therefore, we need to provide some data quality tools like DQ or of great expectations. Another challenge that you might see coming is a lot of small databases. It is not necessarily in this architecture that you would put the whole monster for tens of terabytes, hundreds of terabytes of data, might be even petabytes, but it's not necessarily the case. Maybe the data set that we need to provide that customer wants to acquire is rather small. They would prefer to have simple Postgres database. And in this case, if you get a lot of small databases, we'll end up having quite a bit of those databases that would take space on the nodes, and depends on how often they are used, right? If they are not queried enough, that's something that you can basically look at as a misusage of the space of the node. Therefore, even when we try to build cloud agnostic solution that we can reuse on each and any cloud, we still end up providing some of the databases directly in the clouds from the cloud provider. That sometimes is not very avoidable, I would say. Although we're trying to avoid any vendor lock-ins. Under this, we understand commercial vendors lock-ins that can take some time to migrate in case of emergency or not emergency even, whatever reason can be. And by avoiding vendor lock-in, we can offer this solution to more of our customers. Maybe customer of our customer is interested in something like that, right? Why not to offer one more solution for them? Especially if you have an expertise in Tame. Platformization of all of the things. That is a challenge in itself. It just sounds like it's like, cool, I just create a forum and somebody will fill, but then what will happen? You need to provide a repository, you need to provide the resources, the infrastructure as a code, and all of the things to make sure that it's working. That comes also to the maintenance topic. Maintenance topic is not the simplest one, as it takes, I would say, like huge parts of our efforts. As you have seen, that's a lot of software to maintain, to make sure that versions work smoothly between themselves. Everything is compatible. And whenever you upgrade the Kubernetes cluster, you can imagine how much effort it might be if you're migrating from version like 124, for example, or maybe even older ones. Somebody don't necessarily want to spend time and effort on doing it by themselves. Therefore, we have this cloud, our data ecosystem solution. For example, one of the recent cases was upgrades of Kubernetes to 126 from 124 version. There were a couple of resources that were deprecated. Let's talk, for example, let's take Apache Camel. That's a hot topic in our team right now. Apache Camel operator, known as Camel K, is actually a great tool that helps you to build integrations on using YAML, using Java, using Python, using... Isn't that enough? There are, of course, some ways to build integrations that we are not using in our team in particular. We prefer Java in this case. But whenever you need to upgrade to Kubernetes, that might affect your operators around the cluster, and that was the case for us. Apache Camel operator at the version that we were running was not supporting the latest CRD version of cron job. It is just a bump of the version, but that caused us a lot of effort to update Camel itself, Camel K operator that provisions Camel. It costs us a lot of effort to update each and every integration to synchronize with all of the stakeholders that are using this operator to make sure that they update to the latest version. And what do you know? Maybe you just finished this update and the next one coming. And now you need to provide, to dig deeper into another operator, Istio, for example, or what's not. Support of such a variety of tools, of course, comes with a cost. The question is, how many of those are used at the time? You might end up in a situation when nobody uses Spark for quite a while, or maybe nobody's using Apache Airflow for whatever reason. They just don't feel like it. And teams that required that before migrated to some other tools, right? And in the end, you'll end up retiring some of the solutions. Because that just doesn't make sense to maintain something that is not used. That comes to the standardization of ecosystem of the offerings. And it happened in our team as well, the same way as it happens to majority of the software companies. First, you start with something small, then you get traction, and of course, you start offering more and more and more and more and more because you see there is a demand. But eventually, you'll come to the conclusion that, hey, that's of course great, everything is shiny, our customers are happy, but what about standardization? Maybe you don't need to use each team separate tool. Maybe some use cases can live without some parts of it, like maybe don't use Apache Camel would be nice, and use something else. Maybe you would try to provision Camel separately from the operator. That comes with the costs, sometimes even losing customers that were using one particular tool and nobody else was using it. For example, that happened with one of our offerings for machine learning. Only one team was asking for it, and they were not very much using it on staging environment. And then we faced a lot of issues whenever we came to production, because in this tool, basically every communication, any workload was visible for anybody. That is not something that we can allow in our company, as we are regulated not just by market, so to say, not by our reputation, but also by government. Oh, yes, and therefore we retired some of the machine learning tools that were spawning, allowed some functions approach in our cluster, and now we need to live with that decision. The support was not worthy of it. Amount of effort that it will cost us to bring it to the company standards would not just justify the possibility of serving this particular customer with this particular tool. They ended up using another tools though. Yeah, that's about challenges, about vendor lock-in, about challenges in platformization. And the biggest challenge is to get it work together. Different versions, different interfaces. Every solution have something that they do in their own way, which might or might not be compatible with other tools. As you might have seen, Hive, for example, and Ranger, they are part of the Hadoop cluster of things. Then also Apache Spark. I would like to talk also about the way, how do you choose tools to satisfy your team needs. First, one of the most important parts is to see what the workload is, what people want to achieve, what do they want to do, and basically their plans and expectations. Maybe you don't need something like Kafka for streaming events because you don't have that much of the continuous traffic incoming. Probably in this case, Apache Spark would be the better solution for that would enable batch processing. And you won't need to maintain something like Kafka. Of course, in our case, we do maintain both because we have different customers that require data from different endpoints, and some of them ends up to be updating regularly, and we need to siphon all of the data into the platform. One of the big topics for data meshes is data discoverability. That deserves the whole separate talk. Data discoverability will basically enable team to find the suitable data and maybe request it. If you look at the data, you work with that for a while. Maybe you will get a sample of it. You'll be able to make a judgment call if that suits your business case. If some public data suits your business case, this particular one, you can request it. You request it through the proper channels, but first evaluation and first exposure to the data that you might end up getting is happening through the tools like Data Hub. And of course, Apache Atlas. Some solutions for data catalogization. They offer a lot of possibilities for you. They provide a lot of insights, such as data lineage. They would provide the relevancy, or so to say, how well this data is maintained. If somebody acquired some time-sensitive data 1 year ago, probably it lost its value 1 year after, right? Therefore, by seeing when it was acquired, how often does it update, it offers you to, as a data analyst, to make a judgment call how suitable this data set is for you. And if it is, then you're welcome. Dig deeper. Those are very important parts of any any decoupled, I would say, architectures, the service discoverability in the software side, right? If you cannot, if it's difficult to find some data, you'll probably end up duplicating the work of acquiring it and exposing it, which we would prefer you not to do. Yeah, that's basically it about policies, data quality, and challenges that we were facing. I would say that's about the time to ask any questions that you might have.
So thank you for the great talk. Actually, this is super interesting to look into the use cases of technology. So yeah, we have a few questions. There was a discussion in the chat about Backstage as a IDP platform, self-service platform that is that is used. Can you highlight some like key benefits that you're reaping off this platform and why it's so cool? Because there is like rival solution probably. Why Backstage?
Oh, in our case, Backstage because it's open source. It is maintained by a well-known company, which is Spotify. It have a bunch of integrations, bunch of templates, and why not? I would say that is a good chunk of our documentation source. That is also one of the connection points of our team to the broader audience of the PwC Germany. Whenever you want to request something, you can write your own bits and pieces, of course. You can use some other opinionated solutions. In our case, we decided to go with this solution as we can streamline our offerings in this way. You can basically combine whatever you want out of it. That's like a Lego, right?
Okay, great, thank you. Now to the next question. How big is your team and do you have a SRE role? Because you mentioned a lot of integrations, the huge scope of integrations that is constantly changing. And it would be interesting like to understand how much effort of this and how much effort this constant change requires with a platform like yours.
It requires a lot of effort. It requires a lot of effort to keep everything up to date. It requires a lot of effort to make everything reliable, scalable in time whenever you need it. I would say that all of us are in a way platform engineers, site reliability engineers, and we share those responsibilities between ourselves. I cannot say that one particular person is doing only site reliability engineering, because in the end, all of us are interested that our offering is reliable. Whenever you see the problem, yes, there would be a ticket. Then whenever there is some issue in the monitoring, of course, I didn't mention those tools that we are using for monitoring, like Prometheus, Grafana, all of those bits and pieces. Azure Monitor, for example, whenever we get an alert, we act on it, of course, depending on severity. Some things can wait a little bit, but then probably you should adjust the alert, right? And I would say that the size of our team is around 10 people, including the data engineers and infrastructure engineers. We are working on the Kubernetes on a AKS, which is provided by another team. So we don't bother that much about Kubernetes internals and things like that. We have already plenty on our plate, right? Like whenever the huge workload comes, you need to make sure that Trino, for example, scales its workers in time. And in some cases, it might not. Maybe you'll end up negotiating with the team that is running this query. Hey guys, what are you doing? How often do you do that? And maybe we can come to some conclusions. How can we help each other? For example, running some on a cron schedule, then we can agree with the team that, okay, for this particular time frame, we will scale up the Trino workers, we'll provide them more memory, more CPU, and more workers for this particular query, and fine-tune it.
Yeah, cool, great, thank you. So now we're approaching the pause, and I would suggest everyone to join conversation with Andrii in Discord voice chat and continue asking your questions. And I want to thank you, Andrii, for the great talk. And it's truly something complex and hard to build. And it was super interesting to hear your case. And thank you for joining us.
Thank you very much for having me. I'll be in the Discord whenever anybody have any questions. Please pop up there. See you.
Thank you.